Hey everybody, this is Larry, this is me going Q2, nope, I mean, yes, Q2 of the bi-weekly contest 143, maximum frequency of an element after performing operations 1. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one is only different from Q3 by the biggest number, right? Or like the range of numbers, if you will. And honestly, I did use this as a way to kind of figure that out a little bit, because if n is different, then I'm like, okay, maybe I have to scale n in a better way. But because the numbers were different, I just thought I had to scale the numbers maybe. So then I kind of worked a little bit backwards and thought, okay, what if we don't have to scale these digits? Then can we do something about it? And that's really how I solved this. Like this is a Q2. Q3 is, as I said, the same thing, but part 2, if you want to counter that and a harder problem, the explanation for that problem will be in its own video. So, you know, you want to make sure you have a good basis for Q2 first before Q3. Maybe obvious, maybe not, I don't know. But the way it builds on each other for me, right? So yeah, so the key thing to note here is, like I said, once I kind of got to that point, I was like, okay, well, can we brute force on num sub I, right? Well, not num sub I, but brute force on the number that we're changing to, right? And honestly, this took me a little bit of time because two things during the contest. One is that I just woke up right before the contest and I had some stubborn issues. So if you watch the live portion of it, it is what it is. I ate Chipotle and a half yesterday at night, so it just came out. In any case, but yeah. And the second part that I missed was, the first time I didn't miss. It actually hit everything I needed to, but that's why I was slow. But the second part that the part that I actually missed is the number of operations. If you watch the live portion, I just forgot about the number of operations, and I thought I was just trying to match them. But it turns out that is mostly enough. You just have to figure out the number of operations part, and the number of operations part just allows you to bounce you by the maximum frequency, and this is what I did. Oh yeah. Ooh, actually, that's my Q3 solution, because and the reason why I had my Q3 solution is because if you submit Q3 to Q2, it should still be correct. So that's kind of like a hack, right? Because the only thing that's different is the constraints, right? So that means that Q3 is a superset of Q2 for this problem. So that means that if Q3 is right, or if your solution for Q3 is right, it should also work on Q2. So that's why I did it that way, because if I get a wrong answer, then I already had the right answer, so I didn't have to. Anyway, yeah. But the idea here is just basically, let me actually bring up some drawing board real quick. Sorry, friends. Technology. Who knows how these things work? Okay. Yeah. So basically, the idea here is that, okay, so you have some number x, right? You can or some numbers x, and here's like the number line, say, and you have some number x of 0, say, x of 1, x of 2, or whatever. And for now, without a loss of generality, you can assume they're sorted, right? I mean, if not, you could sort them. So, yeah. And then the idea here is that, okay, well, you know, you have some k length fatness to this, and you just basically just try to figure out what is the maximum thing that we can do within, right? And I will k for size k, and yeah, right? So, and there could be more, of course, right? And of course, k could also be bigger and it will be fatter. So the idea here for me is just, okay, well, this number line, this entire number line, only goes up to 10 to the 5th. I think, is it 5th or 6th? Yeah, 10 to the 5th. So that means that I can try every number. And that's really what I did. I tried, okay, well, try number 1, 2, 3, 4, 5, ... right? But then how do we do that in a good time? Because if we try to do, so there are 10 to the 5th numbers. So if you do it naively, that's going to be 10 to the 5th times 10 to the 5th, which is 10 to the 10, which is too slow. So the idea here is just by, well, If you're sorting, then binary search. So here you have this number, right? That means that in an inverse kind of way. Actually, let me change the colors real quick. Let's say that we're testing this number line as we go from left to right, right? Then now, what are we doing with k, right? Well, it intersects with k if the number intersects with k in the other way, right? Meaning that basically you're saying that this distance is less than k, and this distance is less than k is just basically, well, everything to the left and everything to the right, which is k, right? And that's really it. And here from that, it's hopefully this gives you an idea. But if you are wanting to just listen to me say it, you binary search for the left side and the right side, and then you just get the number of ranges or number of numbers that are inside the range, and you should be good, right? That's really the idea, and I do it for every number. So the way that I did this, of course, because of the sorting, it's going to be n log n, but there is a way that you, I mean, if you see the visualization, you can see that you can also do a sliding window, right? Because numbers on the left pops out, numbers on the right pops in, and that is also very straightforward. The only problem is that there's no problem, but even though this part is linear, you still have to sort, so it gets dominated by sort, so it's going to be n log n. It is going to be faster though in practice, so maybe it's something to consider, but that's basically what I did. I did it with the binary search. I did miss one thing. Hang on, sorry, go back. The thing is that, okay, well, how do we determine, actually I don't think we need a visualization for it. I think the only thing that is missing is this taking into account the number of operations, right? Well, we know how many numbers don't have to change, right? Meaning that if you're trying to solve for x, we know we can just do a lookup table or whatever. Same thing in sliding windows, but just see how many. So same as the number of things that are the same. So changes are basically the entire range minus the numbers that are the same, right? And then now, so these are the changes if we don't have an operation limit, and then here we just want to cap it by the number of operations, so these are the changes, and then at the end it's just same plus changes, and then we just brute force trying every possible number, and that's pretty much it, right? I mean, I actually constrained this by the smallest number and the biggest number. You can kind of just visualize it, right? If you have the smallest number, it doesn't ever make sense to go to the be smaller than a smaller number, because that means that if nothing else, the smallest number is not in it, so none of the numbers are in it. So then that's going to take, even if you are able to match every number, it's going to be less than, or it'll take more operation than just being the smallest number, right? So that's really the idea. And then the biggest number for the same thing. And yeah, the sorting is n log n. This is an O of n loop, or sorry, this is O of b loop. I don't know why I said B, but B for range, and here is log n every time. So this is actually going to be O of n log n plus B log n. So actually, maybe I was wrong on this one in the sense that, I mean, it is directionally correct, but yeah, it is this one. But you can actually reduce this to plus B with no, is it supposed to be? Yeah, I mean, there are a couple of ways you can do it. You can do sliding window with that's O of n with sliding window maybe, and maybe being a little bit smarter on this part. But this is what we do in Q3, so definitely stay tuned for that one. But this is going to be good enough. And even the sliding window is maybe plus n. Plus B or something, depending on how you implement it. There are a couple of ways you can think about implementing it. That's why I kind of write this in a very awkward way. But yeah, that's pretty much it. That's all I have for this one. Let me know what you think, and you can watch me solve it live during the contest next. Okay, looks okay. Have to pause a little bit. Man, I am not awake yet. What's the difference? difference is look exactly the same, but the example there's a little bit different on the example. Num sub I is 10 to the 5th to 10 to the 9. Okay, so 2 and 3 are kind of the same, but we'll see. Okay, let's actually read the prompt first. Given nums to operation k and operation. Select the non-used added integer in the range. Okay. I don't know why they changed examples, it's very weird, but okay. 1, 4, 5. Okay. I imagine people already got this actually, so I don't know. Yeah. Okay, so K, right? I guess the naive solution is just try every number, right? Yeah, let's do it that way. I don't know. Can you do the smart way, Larry? Yeah, it's fine. We'll do it the dumb way first. Something like this, right? No, what am I doing? No. Okay, so we're trying to get all numbers to be I, so then it is just x minus k, x plus k, right? So we're trying. Yeah, okay. Why that doing? Eh. 3 is 15. 15. Why is it 15? Why is this not, why is 15? So 15, huh? Did I misread this one? Adding 0 to negative to num sub 1. Return of any elements. Huh? Am I misreading this problem? Maybe. Only 5 people got it right. Well, they're maybe trying to do the harder one. But oh, number of operations. I forgot about number of operations. Okay. So that's different. Okay, I misread this one. Okay. Focus, Larry. Focus. Okay, so that means that you cannot because I'm doing 3 operations, so you only have 1 operation. Okay, that's not great, actually. Okay, I have to rethink this. Okay, how do I do it? We'll use the restroom. Just woke up and not feeling good. Alright. Not gonna lie. Just woke up, I don't feel great. Had to use the bathroom. Still thinking about this problem. While I was in the bathroom, obviously. There's no live portion of that one, thank you. But 21 people got it, so it's not an easy one either. About Q4. No one's got Q4, so everyone's on Q2. Okay. I mean, I'm thinking somewhat about sliding window, but the answer doesn't have to be. Does the answer have to be one of those numbers? The answer is no, but does it have to be? Wait. I don't know how to do this one. This is so tough. I mean, it's gonna be something like this, maybe, but take no tick. So you can't do anything. What am I doing in this one? I mean, it's up to, right? Because it has to be equal to, I mean, you could just add 0. So, okay. Sliding windows. Yes. Well, okay. So let's say we say x. So there's this, and then it is the number. So this is the number of numbers that would be in the range. How many numbers have to change, right? So okay. So the number of changes is equal to n minus 2. So that's the number of changes. So that means that the same. Okay, no. So the same as f of x. Okay. So it's okay. So actually, same is equal. And so then this is changes is equal to max of this or num operations, and then it is just going to be same plus changes. Okay, that's even more wrong, but and no, it's not. Well, it's so the number of changes is going to be this, not n. It's the other thing that we were doing. Numbers in the range. Okay. 3, which is also still wrong. Oh no, it's min, not max. What am I doing, Larry? 2. Okay. Am I good? I'm just going to audit it. People are slow anyway, so I think I have time to play around. I think this is right though. I mean, maybe I'm doing some silly mistake, but I think this is right. Alright. Okay. Does this work for... This isn't... Oh, no. I was gonna say, does this work for Q3, but... Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.